So we know when we start each equation, there's two things we're always going to do. We've been doing this since the very beginning of the school year. We're going to circle a variable because we want to get that variable by itself. So we're just identifying, I want to get that a by itself. I'm also going to draw the line of equality. Helps me organize my work. Reminds me that whatever I do on one side of the line, I have to do on the other. And for this particular equation, there's actually one more thing that we want to do. This equation has a square root in it, so what do I need to do for this? I want to put a box around the square root. Now the box around the square root is pretty much telling us the same thing the circle around the variable is. We need to get that box by itself. We need to get the square root by itself before I can get rid of it. Now, is there anything I need to get rid of to get the square root by itself? No. So there's nothing I need to get rid of outside the box, so I can jump straight to getting rid of the square root. And how do I get rid of a square root? Square it. So we square the left side to get rid of the square root, which means we have to square the right side. And when we cancel the square and the square root on the left side, that leaves what? A. And on the right side, 7 squared is 49. Now, this equation right here is an equation that you could probably solve without showing that work. You could probably look at this equation at the very beginning and say, well, I know the square root of 49 is 7, so the answer is going to be 49. That's great, but you do need to be able to show the work to support that. So you need to have all this work there. You need to have the variable circled, draw the line, get in the habit of doing that. You should be in the habit of doing that. Box any square roots. What else should we box? What other types of problems are we going to box besides square roots? Squares. So anytime it has a square or a square root, we're going to put a box around it because we need to get that thing by itself first. And then use those inverse operations. In this case, we're using the square to get rid of the square root. All right, in the second one, we have a square. So we're going to do the same thing. We circle a variable, draw the line of equality, and we're also going to put a box around the square. Now, what is that box going to go around? Besides just the square, it's going to go around what? The whole parentheses, right? The 5b minus 6 and what's in the parentheses. So the box needs to go around the parentheses, but not around the 3, because the 3 is not being squared, right? Okay, now what that tells me is I need to get rid of the 3. Since the 3 is outside the box, I need to get rid of that. How am I going to get rid of that 3? We're going to divide by 3. So we divide by 3 on both sides. And on the left side, those 3's cancel each other out, which leaves what? Okay. Can I take the parentheses off right now?
No.
Why not? Because there's still a square there. Remember, the square is on that whole thing. As long as that square is there, we need the parentheses there also. And then on the right side, what do we get? We get 48 divided by 3, which is 16. So we have 5b minus 6 squared equals 16. Now the square is by itself, so I can get rid of it by doing what? Take the square root. So we're going to take the square root on the left side to get rid of the square, and then we're going to take the square root on the right side because we did it on the left side. Alright, so the square and the square root cancel each other out now, which leaves what? On the left side? 5b minus 6. And on the right side, we're looking for the number that multiplies by itself to get 16, which would be 4, or it could be negative 4, exactly. So when we're looking for the number that multiplies by itself to get 16, 4 times 4 is 16, but negative 4 times negative 4 is also 16. So I need another equation where the right side of that equation is negative 4 instead of positive 4. What's going to be the left side of this equation? 5b minus 6. The left side is the same, right? So we get 5b minus 6 on the left, and then on the right side we could have a positive 4, or we could have a negative 4. All right, now what?
Solve.
Now we solve. So to get the b by itself in this equation, we have to get rid of the 6 by doing what? Adding 6. And those 6's are going to cancel, leaving 5b equals 10. And then divide by 5. Those 5's cancel, leaves b equals 2. So there's one of your answers for b. But we are going to get 2 answers here, so let's go over to the other equation to solve that one. We'll do the same steps. We add 6 on this one also. But this time when we add 6 on the right side, what are we going to get? 2. Positive 2 or negative 2?
Positive.
Positive, because the 6 is bigger and the 6 is positive, right? So when the positives and negatives cancel, we're going to have positives left over because there's more positives. Then we divide by 5. And those 5s cancel on the left, leaves B. And on the right side, what is 2 divided by 5? Well, if you punch that into a calculator, it's going to give you 0.4. So should I put that?
No.
Just leave it as a fraction, right? So we're going to leave it as 2 over 5, or 2/5. Can I reduce that fraction? No. You cannot reduce 2 over 5. There's nothing that goes into 2 that also goes into 5. So our second answer is just going to be B equals 2/5. So we could get B equals 2, or we could get B equals 2/5. If we plug either one of these answers in to the equation up here for B, we would get a true equation. We would get the left side equal to the right side. In this case, we would simplify this, and it would end up being 48, whether we plugged in 2 or 2/5. Let's see. To start this one, we'll circle the variable, draw the line of equality, and box the square root. So we're boxing the square root here. It's a little more important on this one than it was on that first one, because this time we're going to have to get rid of a couple of things. And it makes it really easy to see what we need to get rid of. What's outside the box? The 3 and the 7, right? So we need to get rid of those two things before we can get rid of the square root. Which one should we start with? Okay, and how do we get rid of the -7? Alright, so we add 7 on both sides. It's going to cancel the 7. Alright, so everything on the right side besides the 7 comes down, and then on the left side, what do we get? 21, okay. And then we still need to get rid of that 3 by doing what?
Divide by 3.
Okay. So divide by 3 on each side. 3's cancel, leaving the square root of 4c plus 9. And on the other side we get 7. Okay, now can I get rid of the plus 9? No. Be careful. Once we get the square root by itself, we can't get rid of the stuff in the square root until we get rid of the square root. And how are we going to do that? We're going to square it, exactly. So we square the right side, square goes up and to the right, and that means we have to square the left side. On the right side, the square and the square root cancel, leaving 4c plus 9. 7 squared is 49. Could it be negative 49? No. Okay, it's only when we're taking the square root that we could get a negative number. In this case, 7 squared is 7 times 7. There's no way we can make 7 times 7 to be negative 49 because it's a positive times a positive. Now we just solve like we normally do. So next thing we get rid of is the 9. 9's cancel on the right. And on the left, 49 minus 9.
40.
And then divide by 4. 4's cancel, leave c equals 10. So we actually get 10 equals c, right, since the variable is on the right side. This one's different. We don't have to box anything here, do we?
No.
Now, what do we notice, though, when we circle the variables? There's more than one of them, right? So we have d's in 2 different places. So to get the d by itself, we're first going to have to get the d in one place. And we'll do that by simplifying things, and the first thing we do to simplify is distribute. So we're going to distribute the 6. 6 times d is 6d, and 6 times 1 is 6. That's a positive 6, right? And then we distribute this 2. 2 times 2d is negative 4d. Why is it negative? Because this 2 is negative, right? So we're distributing a negative 2 here, actually. And negative 2 times 2d is negative 4d. Negative 2 times negative 3 is positive 6. A lot of people make mistakes on that type of thing. Make sure that when you're distributing a negative number times a negative number, you get a positive number. And then on the other side, we get 18. All right, after we distribute, then we're going to combine like terms. I see a 6d and a 4d. Those will combine to give us 6D minus 4D is
2D.
2D. And then I also have a plus 6 and a plus 6, which combine to give us positive or negative?
Positive.
Positive. So we have 2D plus 12 on the left and still have the 18 on the right. Then what? Solve like we normally do. So we need to get rid of the 2 and the 12.
Subtract 12.
Okay, I would start with the 12. Subtract 12 on both sides. And when we subtract 12 on both sides, those 12s cancel, leaving 2D equals 6. And then
Divide by 2.
get D equals 3. Alright, this last one's kind of like the one before it. The only difference here is that we have E's not only in different places, but they're also
Outside
on they're on both sides of the equal sign here, which means that after we simplify both sides like we did in the last problem by distributing and combining like terms, we're still going to have to do another step to get the E's in one place. So let's start with distributing. Should I add the 2 and the 3 before I distribute?
No.
No. Distribute first. Okay. If we did that, our order of operations would be bad. So we're going to distribute. 3 times E is 3E, and 3 times negative 3 is negative 9. Everything else on the left side will come down, so we bring down our 2 and bring down our minus E. And what should I put here between the 2 and the 3E? Plus, because the 3E is positive. On the other side, we'll distribute the 5. 5 times E is 5E. And 5 times negative 2 is negative 10. And then bring down our plus 15. After we distribute, then we combine like terms. 3E and a minus E combine to give us 2E. So 3E minus 1E is 2E. And then 2 minus 9 is positive or negative?
Negative.
Which one? Negative, because the 9 is bigger and the 9's negative, right? So we've got 2 positives canceling out with 9 negatives. When we do that, we're going to have negatives left over, so our answer there is negative. On the other side, there's nothing to combine with that 5e, so we just bring that down. And then the negative 10 and the positive 15 combine to give us, forgot the e there. What's negative 10 plus 15? Positive 5. Would it be okay if we had over here 5 plus 5e in a different order? It would mean the same thing, right? You remember when we write things, the order we want to write them is the variable first. And if we have more than one variable, then we write them in alphabetical order. But we write the variable first and then the constants last. So that's something that we did during first triad already. Now we've simplified both sides, but we still have e's in different places. So what do we do next? We get rid of the... What? We want to get rid of the 2e because it's the smaller one, right? This is where we're picking on the little guy. So we pick on that 2e by subtracting it, and that's going to get rid of it. And those 2e's cancel, leaves what? Negative 7. And on the right side, 5e minus 2e is 3e, and bring down your plus 5. I know I've said this a lot of times. You could get the right answer if you got rid of the 5e also. The only difference is you would have a negative coefficient. So on the left side, you would have a negative 3e instead of having a positive 3e. So I like working with the positive numbers, so that's why I'm always going to pick on the little guy. Now what? Subtract 5 from each side. When those 5's cancel, it leaves 3e on the right and negative 12 on the left. Good. So the negative 7 minus 5, they're both negative, so we're going to have to combine them to get a total of 12 negatives. And then we divide by 3, and we get e on the right, and negative 12 divided by 3 is negative 4 on the left.